Hello there. I'm glad you found this quiet. The room has softened around you, and your breath drifts in gentle tides, unhurried and safe. Tonight, we'll cradle a small, shimmering question and hold it up to the dim light. Why does the universe seem to resist straight lines? Rivers wander, coastlines fray, trees fork, lightning braids the sky, and even starlight curves when gravity leans on space. Up close, edges blur, roads shimmer with heat, mountains round with time, and the shortest path through space-time is not a rigid rule, but a patient arc. We'll move slowly, the way moonlight crosses a windowsill, visiting meanders in water and blood, spiral arms of galaxies, and the soft mathematics of curves that nature prefers when energy wants ease. No hurry, just a voice in the dark and the steady rhythm of your own breathing as corners loosen and sharp thoughts grow smooth. If this calm keeps you company, a gentle like and a quiet subscribe. Help others find this harbor only if it feels right. For now, let your shoulders settle, let your breath lengthen. The world is rounding off its edges, and we'll follow together, warm, unhurried, and at peace. They say the shortest distance between 2 points is a straight line. In a world that curls and coils and edits every edge with time, that promise melts a little. Follow any path far enough, and it begins to lean. A beam of starlight bends as it slips past a heavy sun, as if space itself had exhaled beneath it. A migrating bird rides the roundness of the earth, tracing a quiet arc you can't see from the ground. A free river wanders left and right, wearing a silver S into the land, patient as sleep. Everywhere, the world seems to choose loops over spears, spirals over arrows, gentle bends instead of strict instruction. So a question settles beside the pillow. Do straight lines truly live in nature? Or are they comforts we invented? They behave beautifully in thought, tidy, obedient, infinite. On paper, they never fatigue. In mud and wind and starlight, they fray. We can walk softly through that thought. Why do galaxies turn like slow hurricanes? Why do vessels in the body braid and branch instead of tunneling narrow and direct? Why does space, something we once pictured as empty and flat, sag beneath the weight of matter and carry time along with it? Even down where things are tiniest, why do particles gather in soft clouds of possibility instead of marching single file? This isn't only a story about shapes, it's a story about motion, growth, and the way living things learn the grammar of the world that made them. Geometry isn't just a rule book, it's a language, and its accent is curved. There's no test here, no race. Ideas can arrive like snow, drift a moment, and melt at the edges. If you drift with them, that's all they ask. The straight line is one of our oldest companions. You can find it pressed into clay tablets and stretched through steel towers, traced in the gridded bones of a city, and along the ruled margin of a notebook. We lean on it quietly whenever we draw a boundary between two thoughts and call it logic. We use it to promise precision, a beam cut true, a wall standing plumb, a plan that doesn't waver. It feels like control, like clarity, like a decision that doesn't second-guess itself. Yet the straight line is more at home in imagination than in weather. Euclid gave it a clean address long ago, a breathless length, without thickness, extending forever in both directions, smooth as certainty, lovely, dependable, and entirely abstract. Out here, branches turn toward light and curve as they grow. Rivers obey gravity, but negotiate with sand. Horizons look flat until you chase them, then they reveal their roundness. the way a quiet truth rises when you keep listening. Mountains heave, coastlines fuzz with bays and inlets, clouds refuse edges. Nature rarely signs its name with a rigid stroke. Even so, we keep straightening. A straight road through forest feels like an answer to wilderness. A rectangular garden tames abundance into pattern. We push tunnels through rock instead of following old paths around it. We string bridges across water rather than walking the patient bend of a bank. We box our rooms, frame our views, lay our maps on a table and call them the world. The more we build, the straighter everything seems, until you step back and see the whole round planet carrying all those lines like gentle creases in a moving cloak. Maps tell on us. We flatten a sphere to a sheet and sketch crisp routes between cities. On the paper, they're straight. On the globe, the shortest path is an arc, a great circle sliding along the planet's curve. Airplanes choose those bows all the time. The eye sees a bend. The distance shrugs and says, "This is the way." Even the tools that promise perfect straightness have their small secrets. A ruler warps with heat and age. A laser drifts across long air, nudged by water vapor and faintly lensed by temperature layers. Wood swells, metal shrinks, stone breathes with the seasons. Nothing holds perfectly still for very long. In our minds, the straight line still carries weight. It means purpose. It suggests honesty straightforward and warns us with its opposite crooked. Architects stack it into order. Designers use it to steady a page. A row of windows, a clean margin, a tidy ledger, all whisper the same hope that life can be arranged. But bodies learn a different lesson. Curves tend to live longer. A stiff branch snaps, a bowed one sways and doesn't break. A channel cut too straight gnaws at its banks. A meander spreads its energy and rests. Arches lift stone by sharing stress in a gentle loop. Shells spiral to grow without tearing themselves apart. Curves are not laziness. They are wisdom ways of moving strength around. The mind seems to like them too. Rounded shapes soothe where sharp corners alert. Perhaps it's old animal sense. Points can pierce, curves cradle. Rolling hills, worn pebbles, a river shoulder, these are invitations. Even the letters we write soften at the edges when we want to be kind. None of this makes straight lines useless. They're marvelous tools. They help us measure, divide, align. They give us grids to count on and axes to draw meaning from. They help a city find its addresses and a bridge find its span. But they're translations, good ones, often necessary of a world that prefers to flow. Zoom far in and light fidgets, grains of matter jitter, the tidy edge blurs into a vibration. Zoom far out and highways curve with the planet, winds curl into gyres, continents drift like patient rafts. The straight line remains a lens, not the landscape. Look up, and it's tempting to imagine space as a clean stage, a velvet plain stretched flat, patient under the choreography of stars. For a long time, people did. Space as empty backdrop, time as a steady drum. Then, the backdrop turned out to be part of the dance. Space stretches, ripples, bows under weight, and time loosens or tightens its tick to match. Place a mass somewhere, star, planet. You and the floor dips, softly but surely. Light takes that slope like water takes a valley, bending not because it wants to, but because the ground beneath it isn't what we thought. Once you see it that way, straightness becomes a local courtesy. The shortest path isn't a rigid line, but whatever the landscape allows, a geodesic, the quiet arc of least effort through a curved world. On Earth, That path hugs a great circle. In spacetime, it leans through a geometry drawn by gravity. A photon sliding past a heavy object doesn't disobey straightness. It honors the deeper map, the way a walker follows the lay of a hill, instead of insisting the hill move. Spin the scale inward, and the same gentleness shows up in different clothes. Electrons don't orbit like tidy planets. They billow in probable shapes, soft clouds where presence is a matter of mostly here instead of exactly there. Paths smear into tendencies. The smallest things seem to prefer a chorus to a solo line, a haze of maybes over a single track. Even the most precise beams we make, the straightest light we can coax, arrive with a grain of spread, a whisper of waviness, built into the rules. Spin the scale outward again, and spirals bloom. Galaxies lace themselves into arms, not spokes. Storms on Jupiter draw ovals that last for centuries. Hurricanes on Earth curl and unfurl like breathing. Seeds ride tiny whirlwinds and settle in logarithmic curls. A sunflower head packs itself with efficiency by turning and turning, bead by bead, following angles that keep crowding from becoming conflict. The universe seems to like arrangements that grow without jamming, patterns that can keep adding without breaking what came before. Even inside us, the body speaks the same language. The heart's vessels branch and branch again, arcs within arcs, reaching everywhere with minimal effort. Airways in the lungs divide like trees until breath can visit almost every corner of tissue. Bones bow to share load. Muscles wrap joints in rounded roots. Nerves coil and loop, not to be clever, but to fit. Movement spreads through curves because curves distribute change, like a hand that passes weight gently from finger to palm. We still reach for straightness when we need it. It's quick to think with. It's good for a beam across a span, for a line of sight, for saying, from here to there, without getting tangled. But the deeper comfort, the one that holds when the world is allowed to be itself, lives in the bend. Water takes the shape it needs and survives. Light follows the slope of space and arrives. Life branches because branching is how to be many places at once without tearing. None of it is rebellion against order. It is order, just a softer kind, one that keeps company with change. If you listen long enough, the straight line reveals its secret. It's an ideal that helps us notice when reality departs, the way a melody helps you hear harmony. The map is flatter than the globe so that pilots can see the sweep of distance. The blueprint is straighter than the building so that builders know where to aim. The ruler is truer than the wood so that hands have something stable to measure against. We invented a clean line to think with, not to live inside. Once, space was the stage and time the metronome. Then came the quiet revolution that made the stage a dancer and the metronome elastic. Mass tells space-time how to curve, and curved space-time tells mass and light how to move. That sentence is wide enough to walk in. It turns a beam's bend into a kind of politeness, a way of keeping pace with the floor beneath it. It turns an orbit into the natural glide of something following the lay of the land, not into a leash tugging it round and round. It even turns gravity from a tug to a shape less a hand pulling, more a bowl inviting. So the world keeps rounding off its corners, edges, weather, paths. Learn to negotiate. Even truth, when it's kind, arrives with softened borders, not to blur meaning, but to fit the curve of how things really are. A ruler on a desk can still be comforting. It gives the hand something steady. Beyond the desk, though, the air stirs. The earth turns, the stars wheel, and light threads through valleys you cannot see. The straight path we draw has its use. The path the universe takes has its own quiet grace. Lying here, with breath like a tide, you can feel both at once. A line to guide the hand, a curve to carry the heart, and the patient wisdom that even the simplest route grows gentler when it bends. Now picture space and time not as a hard floor, but as a soft fabric stretched all around us. Lay a heavy presence upon it, a star, a planet, and the fabric dips. Anything moving nearby follows that slope, not because hidden strings pull at it, but because the ground itself has changed shape. A marble on a rubber sheet arcs toward the bowl made by a bowling ball. It isn't being yanked, only guided by the curve beneath its feet. That is gravity, seen with kinder eyes. Not a reaching force, but the shape of the path. Everything prefers a universe that moves, like us, more easily when it yields. The sun makes a gentle well in that fabric. The earth moves along the edge of that well, falling forever and never quite arriving. Not a rock on a rope, but a traveler honoring the lay of the land. The same rule holds for smaller journeys. A satellite slips through a softer depression around our planet. Even a photon, the straightest thing we know, tilts its route when it brushes past something massive, following the local curve like light through glass, though its speed never changes. This curving showed itself in quiet spectacle more than a century ago. In 1919, during a solar eclipse, astronomers measured the positions of stars near the darkened sun and found them slightly shifted. Starlight had bowed as it passed the sun's gravity. A simple, delicate observation. And suddenly the cosmos felt less like a stage and more like a living field that yields and springs back. Newton's rules still worked beautifully for everyday speeds and distances. They still carry us through most of life. But the why became gentler and deeper. Mass tells space how to bend, and bent space tells matter and light how to move. The fabric is not only soft in space, it's soft in time as well. Space and time are woven together, so when space dips, time stretches. Clocks nestle deeper in a gravitational well tick a touch slower than clocks set higher up. The difference is small but real. The instruments aboard GPS satellites sit farther from Earth's mass, on a gentler slope, so their time runs slightly faster than ours on the ground. Engineers correct for that every day. Without those quiet adjustments, the blue arrow on your phone could wander off by miles. A whisper of curvature turns into directions that actually find your driveway. If a star is heavy enough, it reshapes the fabric so strongly that it becomes a lens. Light from something even farther away splits, arcs, or smears into rings and ghostly echoes. Astronomers call it gravitational lensing. The universe reveals hidden objects by bending their light around closer masses, the way water parts around a stone and meets again downstream. There's a tender irony there. We use a bent path to learn the truth of distant things, our straight beam metaphor giving way to a more generous picture of how seeing works. Think of a pond at dusk. A ripple moves outward in perfect circles from a dropped leaf. Now set a smooth stone beneath the surface. The ripple bends and fans around it, curves slightly, reforms, continues. Space behaves like that when mass and energy are present. Waves of light, orbits of planets, the drift of comets, everything follows the contour it finds. Nothing needs to be yanked or lashed. The curve is choreography, not combat. That's why nothing in the sky travels straight for very long. A moon circles a planet loops a star drifts within a galaxy's spiral, and a galaxy itself leans toward its neighbors. The old instinct says a freely moving thing should keep going in a straight line unless something shoves it. The instinct is sound. The shove is everywhere. Gravity is always part of the room, and the room is curved. Fire a cannonball from a high cliff. With a small push, it drops nearby. With a stronger push, it travels farther before the ground rises up to meet it. With exactly the right speed, the curve of its fall matches the curve of the earth. It keeps falling, but the ground keeps curving away. It never lands. That is an orbit, a graceful, endless fall that keeps missing. Early sky watchers noticed the curves long before they knew why. Johannes Kepler, patient and tireless, compared measurements and discovered that planets draw ellipses, not perfect circles. The sun sits off-center in each path, tucked at one focus. The sky, it turned out, favored a shape that holds a little stretch, as if even heaven preferred a touch of give. Later, Newton explained the reason. The pull between two bodies fades with the square of the distance, and when that rule meets the way motion would carry something straight, ellipses appear naturally. What looked like an exception to neat circles turned out to be the most honest line through a curved world. All those balances are happening right over your head. The International Space Station doesn't hover. It falls around Earth, again and again, more than 17,000 miles per hour, fast enough and high enough to keep missing the ground. Nothing pushes it forward. It coasts on momentum while gravity rounds its path. The station is always dropping. The planet is always curving. The result is a soft loop that repeats and repeats. Not every curve closes. Some paths are wide loops that take decades or centuries to complete. A comet can spend most of its life stretched far from the sun, then dive inward, flare with sunlight, and swing back out along the same ellipse, its year counted in lifetimes. Other paths never return. If something moves fast enough, its track opens into a parabola or hyperbola, a one-time visit written as a gentle escape. Spacecraft sometimes borrow a planet's gravity to change direction and speed, slingshotting, tracing exit curves that spend fuel carefully, letting the planet's well do part of the work. Even the neatest orbits are never perfectly steady. The moon wobbles in its run around Earth. Earth's path around the sun subtly changes shape over long spans. Nearby, masses tug. Jupiter, so large and calm-looking, leans on everything else a little, just by existing. These nudges, perturbations, are like the shifting weight of dancers sharing a floor. No one partner moves alone. Curves fold into larger curves. The moon rides with Earth. Earth rides with the sun rides within the Milky Way. The Milky Way glides toward Andromeda. The pattern isn't clockwork so much as tidework, steady enough to trust, fluid enough to breathe. Once you accept the curve, the world grows simpler, not harder. An orbit stops being a leash and becomes the path a body naturally takes when it honors the terrain beneath it. A beam of light edging past a galaxy stops being deflected and becomes a traveler following the valley it finds. Even time's small changes stop feeling like tricks and become part of the landscape. Lower in the well, slower, ticking. Higher up, faster. Clocks tell local weather. The everyday echoes this tenderness. A thrown ball follows an arc because Earth's pull is in the room with us. A stream cuts a valley by taking the easiest descent it can find. A bridge leans into an arch that shares load along a curve, using geometry as strength. The same reason curves appear in the sky is the reason an archway feels calm to walk under. Stress spreads, paths compromise. Motion chooses grace when it can. There's comfort in knowing the straight path is rarely the path at all. The line we draw on paper is a fine way to think, a clean tool we made to measure and aim. The path the universe prefers is gentler, and it holds more. Even emptiness bends when something heavy is near. Even light listens. Even time is willing to stretch a little to keep the story smooth. A planet circling a star is not disobeying the rule of straight unless forced. It is obeying the deeper rule that the floor isn't flat. A spacecraft slipping past a world while curving outward on a new heading isn't breaking away from gravity. It is conversing with it, borrowing a turn and returning speed. A galaxy lensing a fainter galaxy behind it isn't hiding truth. It is revealing it by bending sight so we can see around corners. The old picture of space as a silent, rigid stage fades into a kinder one. A flexible field that carries everything with patience. Mass whispers to the field, and the field replies by shaping paths. You can feel that logic settling in, the way a lullaby eases breath. The more closely we look, the more the universe resembles water finding its level, fabric taking a fold, a dancer yielding to the floor and discovering balance in the yielding. The myth is not that lines exist. The myth is that they rule. What rules is the curve, the quiet arithmetic of least effort, the soft geometry that holds planets, pilots, and photons alike. Out in that soft geometry, the loveliest surprises keep appearing, rings and arcs in the light of distant clusters. The precise drift of a station that never lands, a pocket watch ticking a shade slower in a valley than on a mountaintop. Nothing shouts, everything nods to the same idea. The cosmos doesn't so much pull as it shapes, and travelers learn the steps. Let that settle, and a familiar night sky deepens. Planets trace elegant falls. Stars glaze the fabric like frost on glass. Ride the path between any 2 points as if it were a thread, and it would feel less like a line and more like a kindness. Out there, nothing runs on rails. The motions we admire aren't puppets on hidden strings. They arise from the room's curve and the way bodies honor it. That is why curved motion feels peaceful. It isn't forced. A planet needs no steering wheel. A moon takes no instructions. Their paths are written into the fabric, inscribed, not in ink, but in momentum and mass, until moving forward and turning gently become the same quiet act. Even our best simulations bow to this subtlety. When people plan an orbital path for a weather satellite, or a probe bound for a distant world, tiny influences matter. A whisper of extra thrust, a hair's breadth shift in angle, and the tidy ellipse becomes a missed encounter, or a bright splash in the wrong sky. The elegance isn't in simplicity, it's in balance. And in that balance, curves are favored. Straight lines appear only where gravity lets go, and in a universe seeded with stars, planets, and invisible wells, gravity rarely yields. Every orbit is a quiet agreement. Momentum would prefer straight ahead. Gravity leans and says, "Here, follow the slope." There is no quarrel, only a dance. From a distance, the steps look slow and serene. Up close, they are precise, endlessly varied, stitched together by the soft arithmetic of curves. Those curves are not empty decoration. They are useful. One of the loveliest tricks we've learned is the gravitational assist, the slingshot. A spacecraft sweeps past a planet and leaves faster than it arrived. Engines resting, tanks untouched. It dives into the planet's well, arcs around, and departs, carrying a little of the world's motion with it. Imagine tossing a ball at the nose of a passing train. Time it just right, and the ball bounces away with extra speed, borrowed from the train's journey. In space, the bounce is a bend rather than a thunk, but the trade is real. the planet loses a speck of momentum too small to notice, and the craft gains a gift of velocity and a new heading. Those assists are the reasons small machines can reach large places. The voyagers left in the late 1970 seconds and used a rare alignment to step from one world to the next, each flyby adding speed and reshaping the path. Without those well-timed curves, their fuel would have been a wish. With them, the wish became a tour, and then a crossing toward the solar system's edge. Precision inside imperfection space is curved. Gravity is subtle, and a small error grows with distance. Yet when it works, it feels like calligraphy at planetary scale, a falling stroke that becomes flight. Closer to home, satellites practice their own grace. Many use ellipses on purpose, dipping low at one end to move fast, then climbing high to slow down. That change in pace lets them linger over a region of Earth or meet a particular time of day again and again. Others hold a different kind of balance. A geostationary satellite circles above the equator at just the right height and speed to match Earth's rotation. From the ground, it seems to hover. In truth, it races along at over 6,000 miles per hour, tracing a perfect ring in step with the planet below. A straight path could never do this. It would drift and keep drifting. The circle is the only way to stand still in a turning world. Farther out, comets offer lessons in long patience. Most of the time, they wait in the deep cold beyond Neptune, dark and unhurried. Now and then, gravity invites them inward. They fall, gathering speed, round the sun in a tight, bright sweep that loosens dust and gas into a shimmering tail, then slip outward again to think it over in the dark. Some return quickly by cosmic standards. Halley's Comet visits every 76 years. Others, like Hale-Bopp, may not come back for thousands. A few are flung onto open curves, parabolas, and hyperbolas and never return at all. No engines, no steering, only mass, momentum, and geometry tracing signatures in space. A comet's path is a record of its past, how it was nudged, who it passed close to, which giant's gravity shaped its course. Jupiter and Saturn, heavy and serene, have edited many such signatures, turning tall, slow loops into sudden dives and new departures. Even missions that stay closer to the Sun borrow these habits. The Parker Solar Probe did not charge straight inward. It curled in again and again, using Venus for gentle assists, each pass tightening the spiral, each curve lowering the floor beneath its feet. Approaching a furnace, stepwise and soft, it has learned the sun by gliding rather than lunging, the way a hand learns heat by hovering first. All of this only works because space bends. If the field were flat and gravity acted like a set of tidy, linear pulls, these maneuvers would not sing. Instead, we see petals and loops in the plotted paths, trajectories that look like notes on a staff or ink laid down by a patient brush. They are not brute force lines. They are partnerships with the room. Falling becomes travel. Travel becomes art. The secret is almost too simple. Everything is falling. A satellite, a comet, a probe, each is in a continuous, exquisitely timed fall. Gravity doesn't shove, it invites. The curve is the invitation made visible. Find a sky dark enough and let your eyes adjust. Through a small telescope, a smudge becomes a whirl, a spiral galaxy, millions of light years away, arms unfurling from a luminous center. These swirls are common, and they catch us first because they resemble something we already trust, a pattern that looks both alive and calm. 2, perhaps 3 grand arms, or more, A pinwheel paused mid-turn. They seem orderly, and they are, but their order is not rigid. It persists by moving. At first, you might expect spirals to wind themselves too tightly. Inner stars circle faster than outer ones. Shouldn't the arms wrap up like yarn pulled from the center? Yet the pattern remains. The reason is a wave hidden inside the whirl. Think of a highway at rush hour. Cars keep moving, but bunches of cars form and travel along the lanes. The jam is real, even though no single car stays in it for long. In a galaxy, the arms are like that regions of slightly higher density that drift around the disk. Stars and gas enter, compress, shine, and then move on. The arm persists because the wave persists. Compression matters. When gas meets the denser sweep of an arm, it feels a gentle squeeze and collapses into new stars. Young stars are hot and blue, bright enough to mark the arm as they burn through their short early lives. Then they age and drift out, and the wave lights the next portion of the curve. The arm is not a fixed structure. It is a pattern carried by motion and made visible by birth. The whole disk turns, but not like a record with everything locked to a single rate. Rotation is differential, faster inside, slower outside. That shear stretches material along the arm and helps keep the grand curve from breaking. The shape is an equilibrium, not stillness, but stability through change. It lasts because nothing tries to hold perfectly still. Look more closely and the pattern deepens. Giant clouds of hydrogen gather where arms have passed, as if the wave left behind a promise of future stars. Dust lanes trace the inside edges of the arms, like charcoal on paper, marking where material is funneled and star-making begins. In places, you can see the timing offset. Dust first, then clusters of hot newborns a little farther along the arc, then older, redder stars trailing behind. It is a chorus sung in rounds, each section entering after the last, all of it moving, none of it random. Sometimes a spiral looks lopsided or split by a bar across its center. Bars are part of the same conversation, a way for a galaxy to redistribute angular momentum, to move gas toward the middle and feed star formation, or even a central black hole. The bar can drive its own set of waves, seeding new arms farther out, shapes inside shapes, all of them born from the simple facts that matter gravitates, motion conserves, and curves are the easiest routes in a bent room. We model these whirlpools and discover a gap. The light we see can't explain how fast the outer stars move without breaking free. The rims circle too quickly for the luminous matter alone to hold them, and yet the spiral holds. The arms endure. The dance goes on. So we listen to what motion is telling us, and add an unseen partner that carries weight without making light. We give it a plain name, dark matter, not to cloak it in mystery, but to be honest about what we know and what we don't. It doesn't glow, but it presses on the fabric, deepening the wells and steadying the swirls, lending a galaxy the quiet strength to keep its grand curve across immense time. Think of it as a hush, beneath everything, mass without color, presence without shine. It outweighs the visible stars and dust by a wide margin, yet it neither absorbs nor scatters light in any way our eyes or cameras can catch. Instead, it signs its name in motion. In spiral galaxies, the farthest stars sweep along faster than ordinary matter could reasonably anchor. If the bright disk were all there was, those stars would fling outward like droplets from a spinning sprinkler. They don't. The measured rotation curves flatten instead of falling, as if an unseen scaffold were extending the galaxy's grip, holding the rim, keeping the pattern intact. What we cannot see behaves like supportive bones beneath a luminous skin, deepening the wells, calming the whirl, and letting the spiral keep turning beautifully for ages. Once you notice that hidden architecture, the spiral stops being just a pretty picture and becomes a working design. The pattern gathers gas, encourages star birth where arms pass, and redistributes angular momentum so the whole disk can go on turning without breaking. It is both ornament and engine, beauty doing useful work. And it is familiar because spirals are everywhere. They rise from ocean heat as hurricanes, each storm born over warm water, spun by Earth's rotation, so that bands of rain and wind braid inward toward a calm, bright eye. The likeness to a galaxy is more than visual rhyme. Rotating matter, pressure and heat, energy released as the structure feeds, all of it traced as a curve through fluid. The same conversation appears at larger scales in the sea. Vast gyres loop slow circles across the basins, hauling warmth and nutrients around the planet, guided by gravity, spin, and the contours of the sea floor. The map of those currents looks like a sketch of long patience, arcs within arcs, drift that becomes design. Shrink the stage, and the spiral remains. A snail's shell turns the problem of growing a home into a simple rule: add on, while keeping the whole balanced. Pour a ribbon of milk into coffee and watch it curl, then unfurl, then thread itself into a soft whirlpool. A sunflower face arranges hundreds of seeds by turning a fraction of a turn each time, avoiding crowding with nothing but constancy. The spiral is a compromise that keeps winning. Grow without losing shape, pack without leaving gaps, strengthen without adding brittle edges. It is rhythm disguised as geometry. In galaxies, the spiral's utility is quiet but decisive. The arms are traffic waves in a cosmic city. Stars and gas move through them, not with them. As material enters a denser band, it compresses, and that squeeze sparks the birth of short-lived blue stars that light up the lane like a festival. They flare young and bright, then fade and drift onward. The arm persists because the pattern persists. As the galaxy turns differentially faster inside, slower out, the shear stretches the arms into long swaths instead of breaking them. Dark matter, present as a dim halo with no shine at all, steadies the outer flow so the pattern can last for eons. The result is something both common and astonishing. A design that emerges from motion, remains because of motion, and carries motion as its meaning. The same logic whispers through storms. A hurricane is a heat engine that organizes chaos, turning warm water and moist air into bands and eyes, outflow and updrafts, the curve doing the work of directing energy. The pattern breathes, intake at the edges, ascent in the spiraling bands, a stillness in the eye that exists because everything around it is moving. Ocean gyres do something gentler but akin. They redistribute, smoothing extremes, carrying floating life and fine silt along roundabout roads that nevertheless arrive. Curves move cargo with care. In smaller, quieter places, the spiral hides in plain sight as a promise of efficiency. The logarithmic spiral, one that grows while keeping its proportions, lets things scale without redesign. The Nautilus adds chambers in a repeating ratio so the whole remains recognizable, each new room fitting the plan the way a refrain returns to a song. A horn that would be straight is a lever waiting to snap. A horn that coils spreads load, keeps the animal's balance closer to its skull, and turns impact into a force the structure knows how to carry. Growth becomes strength because the curve manages stress. Plants write spirals as if they were a language the wind taught them. Pine cones, pineapples, and sunflower heads often show two sets of interlacing spirals, one winding left, the other right. Count the bands, and you will often find friendly pairs 5 and 8, 8 and 13, 13 and 21, neighbors from the Fibonacci sequence, where each number is the sum of the two before it. A plant is not doing arithmetic in the way we do. It is following a local rule that wins over time. Place each new seed or scale at a constant angle from the last near the golden angle, and crowding is minimized, gaps are avoided, and the disc fills evenly. Evolution notices what works and keeps it. The spiral is a packing strategy that outcompetes waste and wobble. There is comfort in knowing that self-similarity can arise from simple rules. A spiral that is the same at many scales is forgiving. It lets the new fit the old without friction. The pattern is excellent at making the most of limited space, energetic budgets, and mechanical constraints. That is why you can find a spiral not only in shells and flowers, but also in the way a fern frond unfurls from a fiddlehead, or the way a vine claims a pole with an easy twist, or the way a chameleon's tail coils so it can grip without strain. It is why a strand of DNA stores instructions in a double helix, two spirals wrapped around each other, stable, compact, and easy to unzip when it is time to copy the text of life. Imperfection does not ruin the song. It writes harmony parts. Real spirals wobble, start and stop, carry scars, and slight asymmetries. The principle persists underneath the noise. Growth that scales itself, strength that spreads, packing that fills without quarrel. Listen inside your own body, and you will hear the same theme. The cochlea in your inner ear is a tight spiral that turns sound into nerve signals, its geometry letting different frequencies settle at different positions along the curve, higher near the base, lower near the apex, so a compact organ can sort a wide range of pitches. Your fingerprints are whorls and loops, because friction ridges grow and split in fields of stress. The curve distributes force and increases grip. Even the crown whirl of hair atop your head is a map of how cells divided and stretched as they laid down the scalp, a little fossil of growth that prefers turning to tearing. The mathematics that haunt these shapes is friendly rather than forbidding. The Fibonacci sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, 34 appears because adding what just happened to what happened before is a good way to remember context while moving forward. Ratios of neighboring Fibonacci numbers approach the golden ratio, and placing things by that angle spreads them across a circle without stacking them on each other. No sunflower calculates. The rule wins because it fits the problem. The plant that fills its face without wasting space holds more seeds. The lineage that holds more seeds gets more chances to continue. Over time, the spiral becomes the accent of success. Spiral logic is also mechanical grace. When material grows outward, added in layers or segments, keeping similar proportions prevents the older structure from becoming a weak lever arm. In horns, tusks, and shells, the curve brings mass closer to support. In tendrils, the coil acts as a spring that can stretch and retract without breaking. In arteries and airways, branching along gently curving paths lowers resistance and minimizes the energy the body must spend to move blood or air. Curves are the body's way of saying yes to change, while keeping function intact. Return to the galaxies for a moment, and the echo becomes clearer. The arms organize chaos and invite birth. The halo of dark matter lends depth to the well so the disk can hold together. Differential rotation and density waves carry the drawing forward without smudging it. What looks like a snapshot is a film still from a very slow movie. Dust lanes trace the inside edges. Then come clusters of hot blue stars, lighting the path the wave just walked. Then older, redder stars, soaking into the dusk behind. The pattern survives because it is a pattern of motion, not a statue. The hidden mass around a galaxy is not an afterthought, but part of the reason the spiral can keep its poise. Without that extra gravity, the outer parts would lag or fly loose. With it, they glide in step. We do not see the dark matter, but we see what it does. Rotation curves that stay high at the edge, arcs that persist beyond the light, weak lensing that slightly stretches the shapes of far galaxies as their light passes through a cluster's unseen halo. It's as if an invisible hand steadies the dancer, so the turn can be held for longer than the visible limbs alone would allow. The spiral keeps visiting in weather and water, city plans and staircases, handwriting and smoke. A tornado's tight coil is a fierce cousin to the broad, slow span of a cyclone. A river eddy curls where the current meets an obstacle, storing energy in a turn rather than a crash. The stair that winds saves floor space while maintaining a safe rise. The cursive script that loops lets the hand move without lifting, conserving motion. Everywhere the rule repeats. Curves spread stress, share space, and let movement continue. Even our tools for seeing the universe carry spirals in their design. Radio dishes feed signals down, flared, curved waveguides. Optical instruments steer beams with lenses whose surfaces are sections of smooth, precise curves. Mirrors in large telescopes are figured to parabolic or hyperbolic shapes, so light from far stars can gather into a crisp point. The straight ray is a fine diagram. The actual path always consults a curve. You do not need to name any of this to feel its calm. Walk a beach and pick up a shell. Notice how it sits in the hand as if designed for it. Watch steam twist from a mug. It climbs by curling because that is how heat and air find agreement. Look at the pinwheel of a distant galaxy through a photograph. Its arms are lanes of becoming. The spiral is not an imposition. It is what happens when rules meet patience. There is something intimate in realizing that our own home galaxy shares a shape with a storm that once grazed a coast, and with a seed head that fed birds last summer, and with a shell that drifted to shore from a life lived underwater. These likenesses are not proof of a single cause, but proof that similar problems invite similar answers. When growth must coexist with stability, when packing must honor fairness, when motion must carry on without waste, the curve returns. It is the universe's way of saying, keep going, but do it softly. The more you look, the more the world answers with the same handwriting. In a drop of water, tiny vortices curl and release. In a galaxy cluster, arcs of lensed light sketch rings around what your eye cannot see. In your ear, a small spiral sorts the symphony of everyday sound. In your fingerprint, ridges loop to steady your grasp. In a field, a sunflower face records a season's work with numbers you can count if you wish. And somewhere far away, the outer stars of a spiral glide on a flat rotation curve, held in the embrace of a halo that does not shine and yet holds everything steady. Spirals are the mercy of geometry. They allow change without breakage, order without rigidity, repetition without boredom. They guide force back into safety, carry information in compact form, and let life and weather and galaxies keep their balance while they grow. Straight lines are wonderful for drawing plans. Curves are how the plans learn to live. Listen closely, and the universe hums the same refrain at every scale. Add a gentle twist, and the whole holds together. That refrain is written under your skin. Beneath muscle and bone, your body is a landscape of gentle curves. Arteries lean like quiet rivers. Veins loop back toward the heart with the patience of tidewater finding home. Tiny bronchi branch and rebranch into an upside-down tree, ferrying breath to the furthest rooms of the lungs. It isn't a tangle of tubes, but a tuned network where bends and arcs appear with purpose. These curves aren't accidents. They're how life flows, the same soft geometry that steadies galaxies, teaching your body, too, how to move and endure. Engineers learn early to favor soft bends over sharp elbows. Sudden angles make turbulence eddies, pressure spikes, little storms that steal momentum and wear things down. Your body follows the same wisdom. Each artery and vein curves just enough to keep blood gliding instead of colliding, easing the stress on vessel walls and discouraging the chaotic swirls that can lead to clotting or uneven pressure. Fluid dynamics, how liquids and gases move, offers two broad moods, laminar and turbulent. Laminar flow is smooth and layered, like silk sheets sliding over one another. Turbulent flow is busy and unpredictable, full of vortices and pressure bumps. Turbulence has its uses, especially for mixing, but delicate systems prefer calm. Your circulation leans into laminar whenever it can. The heart sends blood forward with real force. If vessels were perfectly straight, each surge would crash into the next segment and rebound as a pressure wave. A well-placed curve diffuses that shock. The blood arcs around the turn, guided rather than blasted. The result is durability walls that last through seasons of use and efficiency. A long-distance transport system that doesn't need to shout to be heard. Even the aorta begins with a soft bow. It rises from the heart in a gracious arch, then tilts the momentum downward toward the body. That sweep isn't a static flourish on a diagram. It's a redirection that conserves energy and reduces wear while keeping the flow full and steady. Your airway copies the same logic. From the trachea down, the passages split like a tree turned to face the earth. Main bronchi, smaller bronchi, bronchioles, and finally, the tiny sacs called alveoli. The shape repeats at smaller and smaller scales, a fractal written in air. That repeating pattern creates astonishing surface area. Fully expanded, your lungs offer on the order of 700 square feet, for gas exchange about a small apartment tucked gently beneath your ribs. Curves here don't just save space, they also slow the breath at the right moments. As air travels deeper, its speed eases, giving oxygen time to cross the paper-thin membrane and slip into blood. If airflow stayed fast and straight, the exchange would be rushed and wasteful. A curve functions like a ramp, inviting pace to settle into usefulness. Curves are strength too. Straight structures under changing load are prone to buckle. Arches distribute stress and hold the line. Bridges lasted centuries on that principle. So do vessels and airways. A gently bending tube can stretch, swell, and recover with each change of pressure. It absorbs surprise without tearing. Consider the daily workload. Your heart beats more than 100,000 times, moving blood through more than 60,000 miles of vessels, enough to circle the planet a couple of times and keep going. A rigid, ruler-straight system would fatigue and fail. A system built from arcs and give quietly endures. Evolution favors that resilience. Animals that learned to move blood with less turbulence and less wall stress had an edge, especially as bodies grew larger or more active. Fish, birds, mammals, different blueprints, same preference. Looping, branching vessels move life's cargo efficiently while protecting the roads that carry it. The pattern repeats at the smallest scales. Capillaries take curved paths between cells, delivering oxygen and nutrients, then winding on to the next neighborhood. The routes are redundant by design. If one corridor is blocked, neighbors can share the load, and these networks aren't static. The endothelial cells lining your vessels pay attention to flow. Laminar makes them content, turbulence makes them bristle. In response, the body subtly widens or narrows passageways, reroutes flow, or summons repair. Geometry adapts a little at a time to keep the story smooth. It's humbling to realize how much is happening beneath the surface without a single conscious instruction. Each breath wanders through a spiraling architecture that adjusts to volume and pressure on the fly. Each heartbeat launches a wave into a curved map written by long practice and longer ancestry. No effort on your part is required. The body solved the geometry long before you learned the word. In the end, curves are survival as well as beauty. They let motion continue, limit damage, and give complex organisms room to thrive. Straight lines can be quick, but they're brittle. Nature meanders, coils, and adapts. The result is a system that lasts a lifetime. Every inhale, every pulse, every stream of blood is a duet of branching and bending. A resilient network shaped by the quiet logic of movement. A whispering miracle that prefers spirals and arcs, never rushing, just going forward one gentle bend at a time. Look outward and you'll see the same handwriting in branches everywhere. A tree reaching for sun, a river finding sea, a bolt of lightning stepping from cloud to ground. They all fork with a rhythm that feels improvised, yet inevitable. At first glance, it looks chaotic, a confusion of splits inside splits. But if you linger, order emerges precise, repeated, and efficient. Consider a tree. From the trunk, thick limbs angle outward and up. Those limbs divide into smaller branches, which divide again into thin twigs and leaf stems. This is not just growth in all directions. It's a delivery plan. Light gathered by leaves, water lifted from roots to canopy, wind's force distributed so wood can flex without breaking. The structure must be broad yet light, strong yet forgiving. Each fork negotiates these needs with a familiar solution. Trees are not alone in that choice. Rivers also branch. A trickle begins high in the hills, fed by smaller rivulets, themselves fed by even finer threads. Downstream, channels meet and part, then meet again, mapping a basin in lines that echo a tree's silhouette. Dendritic, we call it from the Greek for tree. From above, a watershed looks exactly like a flattened forest, gravity drawing lines on the landscape according to the terrain's advice. Then there is lightning. When charge builds in a cloud and goes looking for ground, it doesn't drill a clean corridor. It tests many routes at once, splitting and probing through air that offers different resistance from place to place. Some tries dead end, others reach farther. Eventually, one path completes the circuit, and the main bolt surges along the channel, already carved by those tentative leads. The bright line we see is the finale, not the search. The branching isn't imposed from outside. It arises from local rules. Trees branch to maximize light and minimize weight. Rivers branch because gravity is simple but land is complicated. Lightning branches because electricity prefers the least resisting road through air. Different materials, different forces, same family resemblance. That resemblance is a sign of fractals patterns that repeat their character across scales. A small twig looks like a big branch. A tiny stream resembles the river it feeds. A short segment of lightning holds the same jagged personality as the whole stroke. Fractals are nature's way to solve complex problems by reusing a simple idea. Need to cover a lot of surface area without spending too much material? Branch. Need to carry nutrients, drain rain, or distribute energy in a wide space? Branch again. Keep dividing, keep narrowing, and you get reach without waste, coverage without clumsiness, stability without stiffness. The same approach shows up inside you. The bronchial tree in your chest splits roughly a few dozen times from trachea to alveoli. Each division multiplies surface area for gas exchange, while keeping the whole organ compact enough to fit comfortably under bone. It is architecture built from repetition and curve. No blueprints, no overseer, just local rules played over and over until the shape can do what it must. Fluid systems prefer these designs because they calm the flow. Every gentle turn delays chaos. A steep corner makes an eddy. A soft bend lets layers slide. The endothelium, that thin satin lining of vessels, reads the story in the movement against it. Smooth, directional flow encourages health. Erratic swirl writes irritation. Given time, vessels remodel themselves, micrometers here, micrometers there, to favor the laminar tone. Nothing is perfectly straight, because nothing stays perfectly easy under pressure if it is. Curves are compromise made permanent. Numbers, when spared and simple, help the picture settle. Your lungs' complex branches grant that apartment-sized exchange area without taking more space than a pair of cupped hands. Your vessel's 60,000-mile network visits almost everything, then visits again, with backups etched everywhere. Your heart's 100 to 1,000 daily beats ride the same arcs: rise, turn, descend, deliver, and the walls stay whole because the geometry spreads the work. You carry in your chest and limbs the same conversation trees have with wind and rivers with stone. Bear the load, share the load, let the shape do half the job. Even the tiniest details keep the theme. Capillaries wander in curves between cells to shorten the average distance from supply to demand. Some paths are favored, others wait as reserves. When injury or obstruction appears, those sidelined paths become main roads, opening like side streets when a parade blocks the avenue. The nervous system branches as well. Neurons cast dendrites that fan-like roots, collecting signals from a broad field and guiding them toward the cell body. The form resembles a winter tree because both are trying to touch as much as possible with as little as necessary. The branching and the bending are companions. Few real forks meet at crisp right angles. Right angles would produce little whirlpools and trapped pockets. Instead, merging rivers curve into each other. Bronchi splay into gentle Ys. Lightning's forks ease apart at grades that balance the field. Curves allow motion to keep its composure. If you want your body to explain its choices in its own language, listen to the flow. When it is laminar, the tissues hum along and heal. When it is turbulent, the message is, fix this. And the body does, with the quiet diligence of a caretaker. Open here, narrow there, steer a little to the left, bring more help. The vascular network is never once and done. It is constantly edited, a living map that updates itself to keep the routes smooth and the loads fair. Repetition is the soft intelligence of the natural world. A small rule, applied again and again, builds something vast. Each branching, each bend, increases surface area, adds a margin for error, and gives the system a way around trouble. When you inhale, you operate an upside-down forest. When blood flows, it follows the geography of a river basin you carry inside yourself. When summer storm clouds flicker and a spear of light climbs down the sky, you recognize the silhouette because it's been with you all along in the lace of your lungs and the lace of leaves overhead. Nature loves curves because curves are generous. They let force pass through without breaking what holds it. They spread stress and invite motion to continue. They increase reach without heaviness, reduce risk without paralysis. Straight lines are excellent for drawing a plan. Curves are the plan learning how to live. Between the branching and the bending, there is a sentence the world repeats at every scale. Add a gentle turn, and the whole will last longer. You are living that sentence. Every breath is a soft spiral. Every heartbeat is an arch. Your blood runs through slender rivers. Your air travels a miniature canopy. Your nerves send quiet lightning along branching paths. No fanfare, no commands. Only movement that knows how to yield and still arrive. That is how a body endures, by trusting curves steady as water that learns its shore and keeps going. Coral reefs, fungi, and neurons all draw from the same quiet alphabet. They live in different worlds, saltwater gardens, damp soil, dim rooms inside the skull, yet they face the same riddle: how to reach farther, connect more, and deliver what's needed without wasting strength. Branching answers that riddle again and again. It is a universal blueprint for making complexity out of simple rules, a way to keep spreading without falling apart, to cover more ground while carrying just enough material to hold the shape. Those curves and forks aren't arbitrary, they are tuned. Nature doesn't scatter branches like confetti. It angles them with a thrift you can feel, even if you don't name it. Rivers space their tributaries in ways that share the load and soften erosion, allowing water to pass along the terrain instead of cutting it to shreds. Trees tilt their forks so leaves can take the light without smothering each other. Even lightning, wild as it looks, follows statistics that physicists can model its branching depth, its angles, its tendency to step, pause, and step again. What feels like chaos is a truce among competing needs: strength and flexibility, reach and economy, speed and precision. A bolt could dive straight down, but that path costs more resistance and lowers its odds. A tree could try one massive leaf, but it would shade itself and snap. So the world keeps splitting the difference. Forks, arcs, spirals, choices that let things grow and still hold. Branching also builds in spare grace. If a limb breaks, another picks up the work. If a stream dries, side channels shift to carry the flow. Resilience in nature rarely looks like a fortress. It looks like many routes to the same place. Curves are partners in that resilience. They bend rather than shatter, store stress instead of focusing it into a fault, and give the living thing time to adjust. Our own designs borrow from these patterns, deliberately and by instinct. Look at road maps, power grids, water mains, fiber lines. They spread with branches when the goal is to reach many addresses without emptying the budget. We tend to favor neat symmetry, straighter avenues, sharper angles, tidy hierarchies, because they're easier to draw and count, and because straight lines whisper control. Nature is kinder. It leaves room for irregularity, small deviations that prevent the whole from ringing like a brittle bell. That gentle departure from perfect order is often the difference between a system that hums and one that fails the first time something unexpected arrives. There's a human softness to these shapes too. People often find fractal patterns calming, especially patterns that echo trees, rivers, and coasts. You don't need to memorize equations to feel it. Walk a forest path or study a satellite photo of a delta. Your eyes relax as if they've come home. The brain seems to recognize these arrangements without being told why. They are efficient, yes, but they are also familiar, like a song you've known since childhood that you only now learn the name of. Underneath is a deeper rhythm. Nature does not draft designs. It evolves. It tries, keeps what works, and quietly edits what doesn't. The shapes that persist are the ones that solve old problems gently, moving energy without waste, spreading material without strain, surviving bad weather without splintering. Over and over, the winners are curved, branching, and quietly mathematical. From the tallest cedar to the flick of a summer storm, from trickles on a hillside to synapses speaking across a gap, the motif repeats, not because the world is copying itself, but because the same rules keep meeting similar tasks. Energy flows more kindly when it arcs. Materials reach farther when they branch. Systems endure longer when they divide the work. Order doesn't demand straight lines. It needs breathing room to split and spread. Even light, swift and sharp as it seems, shares that tendency to yield. It races through vacuum at nearly 300,000 kilometers per second, a speed that feels like certainty. Yet its path bends easily when the world asks it to. Dip a straw into a glass and watch it kink at the water's skin. That little jump is refraction, light slipping from air into water, slowing just a touch, changing direction because the medium changed its pace. It isn't trickery. It's geometry playing out, angles answering to speed. That same bending is the work of lenses. Curved glass or plastic reshapes light so it can focus, spread, or correct. A convex lens gathers rays toward a single point. A concave lens lets them drift apart. Eyeglasses, cameras, microscopes, telescopes. Each is a conversation between curve and beam. The lens tells light where to go, and light, obedient to the local rules, goes there. Rivers obey banks. Light obeys contours. The line we imagine is always a path in context. Air itself makes lenses. Layers of warm and cool air refract light differently, so a summer road becomes a hall of mirrors. You look ahead and see a shimmering pool that never arrives. The heated air just above the asphalt bends light upward. Your eyes accept the detour, and your brain, helpful as ever, calls it a reflection. In deserts or across cold seas, the pattern flips. Cooler air near the surface and warmer air above can bend light downward instead, floating distant hills into the sky in a superior mirage. Direction, it turns out, is only as straight as the last bit of air your light has walked through, and air loves a curve. Rainbows make the lesson cheerful. Sunlight enters raindrops, bends, reflects inside, and bends again on the way out, splitting into colors as if the sky had been laid over with glass threads. Each drop sends the right color your way, only at a precise angle, about 42 degrees from the point opposite the sun, and that fixed angle paints a circle around your shadow. We usually stand on the ground and see only the arc. From a plane, you might catch the full ring. Halos around the sun or moon follow a sister rule. High ice crystals, often hexagonal, refract light into a ring at about 22 degrees. The crystals differ, the angles change, but the message is the same. Light moves through what's there, and the curve is revealed, not imposed. Even shadows, which we like to imagine as knife-edge truths, carry softness. A distant lamp makes a sharper line than a nearby lamp, because sources have size. The sun is a disk, not a point. Light from one edge arrives at a slightly different angle than light from the other, and the boundary between dark and bright becomes the penumbra, a gradient that records the sun's breadth. Eclipses write curvature on the sky with the same ink. The Earth's shadow crossing the moon is rounded because both bodies are round. The geometry of the edge tells you the shape of the thing that cast it. Then there is gravity, the grandest lens. Space and time form a fabric that mass quietly dense. Light always tries to take the straightest possible path, but in curved space, straightest is an arc called a geodesic. Slide a beam alongside a star or a galaxy cluster, and its route bows, not because it slowed down, but because the floor changed under its feet. Sometimes the bend is subtle, sometimes it is dramatic. Distant galaxies arcing into smeared crescents and rings around heavy neighbors in the foreground. We call those bright loops Einstein rings, and they are proof, written in light, that the path depends on the room. Gravitational lensing lets astronomers see what would otherwise hide faint galaxies magnified by a cosmic magnifying glass, and even the presence of dark matter traced by the way it steers passing light without shining itself. Across all of these scenes, lenses and mirages, halos and gravitational arcs, the same quiet idea returns. Light does not insist on a line. It accepts the curve that the world offers, through glass and water, through layered air, through the soft well of gravity. Even your own eye is a temple to bending. A transparent cornea and a living lens curve light toward the retina. If the curve is too steep or too shallow, the focus lands short or slips past, and the world blurs until a new curve, glasses, contacts, sets the path right again. Vision is the art of guiding beams, and seeing is literally a map of how gently they were turned. It's easy to picture light as a rigid spear because a flashlight draws a neat cone in a dark room. But that tidy shape was carved by glass, crafted by a reflector, and colored by air. In practice, light flows. It refracts, reflects, diffracts, spreads, and loops, choosing what looks like a curve, because that is where straight lives when the ground itself is curved. The same patience that teaches a river to follow a bank teaches a beam to follow a lens. The same thrift that leads a tree to branch leads a neuron to fan its dendrites, and a coral to extend its colony, cell by cell. The universe does not need straight lines to be clear. It needs rules that leave room to bend, and it has them. So the pattern goes on. Coral heads bloom in rounded stacks that feed the reef without overloading it. Fungal mycelium threads soil in branching lace that finds nutrients and shares them. Neural forests grow in the dark, pruning and reconnecting until signals can take many paths to arrive at meaning. The branching builds reach. The curve keeps the structure safe. Together they make systems that do not break when one root closes, that do not shout when a whisper will do, that prefer the slow generosity of many choices to the brittle certainty of one. And even the light that lets you witness all of this is part of the same kindness. It bends to meet your eye. It takes the long curve home. Light is a good listener. It takes its cues from the room it's in, and the room is never uniform. Air ripples with layers of heat and cool. Water thickens the path. Glass curves a quiet instruction. Gravity loosens the floor. What looks like a single, unwavering line becomes a chain of small agreements. A sunbeam threads the atmosphere, bent a little by density changes, scattered by dust, bent again as it slips through a raindrop, split into color, then nudged once more by the gentle curve of your own eye's lens before it turns into a picture your mind can hold. That's a long, intricate journey for something we often imagine as perfectly straight. The small detours are the reason we get rainbows and halos, red sunsets and mirages, starlight leaning around invisible masses. The wonder isn't that light resists bending. The wonder is what shows up when it allows itself to bend. Hold a globe in your hands and stretch a string from New York to Tokyo. Pull it tight and you'll see the string arc north, skirting the Arctic in a graceful rise. On a flat map, that bow looks like a strange detour. Inside the roundness of Earth, it's simply the shortest way. Our planet is nearly spherical, slightly squashed at the poles, a touch swollen at the waist, and on a sphere the straightest path has a different name. Slice the globe with a plane that passes through its center, and you draw a great circle. The equator is one. Any meridian, paired with its opposite, is another. Airplanes follow these arcs whenever they can, which is why routes that look eccentric on paper, curving over Alaska, grazing Siberia, are, from the airplane's perspective, the sensible choice. Fewer miles, less fuel, less time. The curve you see on the map is an artifact of flattening. The plane is flying the world's version of a straight line. Brains grow up on rectangles. The maps we learn are sheets that stack and hang nicely on walls. But any attempt to press a sphere flat will stretch something else. The Mercator projection, beloved by sailors, preserves compass bearings as tidy straight lines and pays for that gift by inflating sizes as you approach the poles. Greenland swells to rival Africa on paper, though Africa is more than 14 times larger. Great circles, straight on a globe, bow into loops across a Mercator map. Other projections choose different compromises. Robinson spreads distortion more evenly, so continents feel more proportional. Winkle Tripole balances area, shape, and direction. Goods Homolocene slices the oceans like orange peel to preserve land areas more faithfully. Each method saves one virtue, distance, angle, shape, or area, by letting the others slide a little. We plan road trips, trace flight paths, and memorize borders on these imperfect surfaces, forgetting that straight on a map may not be straight on the Earth that carries us. Cables laid across oceans follow great circles. Migrating birds climb sky curves that look roundabout but stretch their energy farther. Navigation systems measure distance with spherical trigonometry under the hood, so your blue arrow lands at the right driveway. Even a walk that feels arrow straight is an arc across the planet's skin. If you truly kept your feet in a perfectly straight Euclidean line, ignoring gravity and the ground, you'd rise gradually away from the surface. Straight lines and curved worlds don't shake hands easily. Surveyors and engineers keep the peace with care. Over long distances, a laser shot straight will ride above the ground because the Earth has slipped away beneath it. The misfit is small at first, on the order of inches over a mile, but it compounds fast. Curvature arranges vision too. Ships sink hull first beyond the horizon, not into the sea, but behind it. Sunrises and sunsets shift with altitude. A higher viewpoint sees further along the round, so evening lingers on mountaintops and in tall towers. Astronauts in low orbit watch day and night pour over a blue sphere, a moving shadow that refuses any story of flatness. The horizon itself bows gently, though most days our eyes and minds prefer to iron it smooth. We pour cities onto that subtle curve, using right angles and straight avenues, and the streets serve us well. Beneath the grid, the Earth keeps rounding away. Skyscrapers that seem perfectly parallel are, in truth, ever so slightly splayed at the top. extend their lines forever, and they would meet at the planet's center. It's not a flaw. It's a quiet reminder that rulers and maps are translations, useful, honest, incomplete. To reach the shortest distance between far-off cities, we let our path arc. The flight from Los Angeles to London that finds itself over Greenland isn't wandering. It's obeying the globe's own geometry. Efficiency hides inside what looks like a curve. Space shares its gentleness with time. For a long while, people trusted time to behave steady, universal, a perfect beat. Clocks ticked, calendars marched, mornings and evenings traded places in a rhythm so dependable you could hang your life on it. Then the same insight that softened gravity softened time. Mass and energy warp the room we live in, space and time joined into a single fabric, and everything moves along the folds. The surprise is that time folds too. Where gravity is stronger, seconds lengthen, and fewer of them fit into the same slice of experience. Where gravity eases, seconds are a shade shorter, and more of them fit. The effect is tiny near us, but it is measurable. Set one atomic clock on your desk, and another on a high mountain. The higher clock, a bit farther from Earth's center of gravity, ticks a touch faster. The difference hides in billionths of a second, but it's there. Gravity leans on feet and moments both. Ordinary days blur that difference away. Devices that stitch the world together cannot. The navigation in your phone depends on signals from satellites about 20,000 kilometers above the surface, each carrying an atomic clock and whispering the exact time. Your phone listens to several at once, measures how long each signal took to arrive, and triangulates where you are. The satellites are moving fast, and they sit high on the gentler slope of Earth's gravitational well. So two small tilts in time appear at once. Their speed, according to special relativity, makes their clocks tick a little slower than ours. Their altitude, according to general relativity, makes their clocks tick a little faster than ours. Add the effects and the satellite clocks run ahead of ground clocks by about 38 microseconds per day. Tiny by any ordinary measure, enormous for navigation. Leave that drift uncorrected, and your map position would wander off by kilometers within a single day. Engineers account for both kinds of time bending from the start, so your route home fits in the palm of your hand. It's comforting, in a way, that time and space keep the same manners. Neither is stiff, both are responsive, both draw curves where we once sketched lines. That same courtesy is what makes sunset linger, light traveling through more atmosphere at a shallow angle, reddened by the extra path, and what paints a rainbow light slowed, turned, and separated inside droplets at specific angles until it lays an arc on the sky. It's what builds halos around the sun and moon, ice crystals catching and bending light into rings at about 22 degrees, and what spreads the edge of every shadow into a penumbra because the sun is a disk, not a point. It's what allows distant galaxies to show us their lensed echoes, stretched into faint arcs by foreground mass that refuses to shine. The world's unevenness is not an insult to clarity. It's the source of most of the beauty we actually notice. Maps teach the mind one story. Landscapes teach the body another. We navigate in straight segments because it's handy. We travel best by curves because the world is round and the room is bent. Bridges look straight, but lean into arches for strength. Roads that seem true on paper roll with hills to spare engines and brakes. Flight paths bow toward cold air and tailwinds, measuring the sky with more than distance alone. The arc is not a concession, it's a gain. What appears crooked is often correct. What looks like a detour is often the quickest way through. A path that bends can hold two truths at once. It feels gentle, and it saves time. Even at the scale of a thought, a small bend can be wise. We like rules that line up cleanly, yet the universe keeps handing us curved versions that work better. Straight is a great tool. Curvature is how the tool meets the world without breaking it. Light gives up a little certainty to show us color and depth. Airplanes trust a northern rise to shorten an ocean. A clock on a mountain hurries a hair. A clock by the sea relaxes. None of this chaos is careless. It's choreography. Try to picture the journey of a single ray of light at dusk. It leaves the sun, crosses the vacuum between worlds in a mostly straight sprint, meets the upper air, and slows a fraction, which tips its path. Dust scatters some of its companions aside, painting the horizon in oranges and reds because shorter wavelengths bounce away more easily. A thin cloud high in the sky acts like a lens, easing the ray around its edges. The ray meets your cornea. Another curve passes through your living lens. One more curve and lands on the retina. Everything along that route negotiated gently with the ray. None of it shouted. The sunset you see is the sum of all those compromises. A field of curves written as color. The same modest give lives under your feet. Every mile of road is laid on a planet turning under you, falling away from you at a rate you can't feel but must respect to build long things right. Survey crews account for it. So do the designers of pipelines and tunnels. A level that is truly level over a long distance does not coincide with a straight line in space. It follows a curve parallel to the ground. The distinction matters in steel and stone, and it matters in thought. Straight is what we draw to think. Curved is what we follow to arrive. That's the pattern that keeps returning like a melody. The shortest path across a globe is an arc. The cleanest image is born of bent light. The most precise navigation blends two kinds of time and corrects for both. The most faithful maps admit their distortions and choose where to place them. None of this takes away from the worth of straight lines and steady beats. It simply puts them in their place as instruments we made to guide our hands, not as laws the universe must obey. There's a quiet kindness in all of it. When a flight climbs over winter ice to save an hour, the earth is offering an efficient curve. When a rainbow leans into a storm, the air is showing the math of droplets without a single number. When your phone finds you on a crowded street, invisible clocks and patient geometry are bending time and space into a little blue dot. The straight path we assumed was universal becomes one option among many. The arc becomes a lesson. Sometimes the fastest way home is the one that looks like it wandered. So the world goes on doing what it does best, rounding off edges, adjusting pace, letting rules meet reality without snapping. Planes reach across oceans by rising into the high latitudes. Light paints and reveals by surrendering a sliver of its straightness to the rooms it enters. Time keeps perfect honesty by admitting it is local. Under the gridded logic of maps and streets, a soft planet continues to curve. The more closely you look, the more the lines you trusted resolve into threads of small bends, each making the whole more accurate, more efficient, and, somehow, more soothing. In a universe like this, the journeys that matter aren't the ones that insist on straightness. They are the ones that learn where to arc. If those tiny corrections weren't there, your phone would place you miles from where you stand, and the neat lattice of streets would come apart. To keep the world stitched together, engineers bake relativity into the code. Every time you ask for the nearest coffee shop, a little piece of Einstein rides along with the route. It's a quiet astonishment. Modern life depends on the curve of time. The curve gets steeper near heavy things. Gravity doesn't only bend space, it tugs on seconds. The stronger the field, the slower clocks run. Drift close to a black hole, and time slacks dramatically. If you could orbit just outside the point of no return and remain intact, an hour for you could rhyme with years for someone watching from far away. That isn't fantasy tucked in the margins. It falls straight out of the math, echoed by observations that show clocks and light losing their usual pace near deep gravity wells. Time isn't a single river running the same speed everywhere. It is local, shaped by where you are and how you move. In the comfort of ordinary days, time feels absolute because we share roughly the same gravitational weather. Step away from that, whether rise into orbit, fall towards something massive, or rush fast enough, and the differences cease to hide. Speed trims time, weight stretches it. Move quickly through space, and you experience fewer beats than a friend who waited behind. Rest near something heavy, and your minutes grow long. It's as if every place in the universe keeps its own tempo, not by whim, but by mass and motion. Even the person who carried these ideas into the world felt their strangeness. It is unsettling to imagine your heartbeat tied to altitude, your minutes leaning with momentum, the path of your life not a straight timeline, but a gentle spiral through spacetime. Yet there's a kind of mercy in it. The universe is built less from rigid scaffolds than from relationships. The seconds you live are sculpted by the shape of the room you're in. Time doesn't merely pass through space. Together, they make the room itself. Bend one and the other agrees. Talk about the geometry of the cosmos, and you're really talking about the geometry of experience. The tracks matter and light can take, and how long those tracks feel underfoot. None of this makes time unreal. It makes it more generous. Like light, it bends. GPS whispers that truth from 20,000 kilometers up. Its satellite clocks pre-adjusted because motion slows them a little while, altitude speeds them a little more. The net drift, about 38 microseconds each day, sounds like a nothing. Yet left alone, it would send your blue dot wandering by kilometers before dinner. Mountain clocks tick a touch faster than their sea-level twins. Black holes bellow the same lesson where gravity is strongest. We live where gravity doesn't just pull, it edits our passage through moments. The world, then, is layered and curved not only in space, but in the unfolding of time. Seconds don't march like soldiers. They flow, they loop, lean, and stretch. Understanding that curve doesn't make time less mysterious. If anything, it makes the mystery ring clearer, the way a bell's tone deepens when you hear the space around it go smaller, and strangeness blooms. At the tiniest scales, the universe stops behaving like a tidy machine and starts shimmering with maybes. Objects blur into clouds. Motion becomes a matter of likelihood. The crisp paths we try to imagine little arrows from point to point dissolve into a soft haze. Take the electron. The old picture, tiny planets circling a nucleus, was comforting and wrong. Electrons don't loop in little rings. They don't trace anything we can call a path. Instead, an electron exists as a spread of possibility, a probability, cloud thick in some regions, thin in others. Ask too hard where it is, and your grip on how it's moving loosens. Measure its momentum cleanly, and the location smears. This isn't a failure of instruments. It's a limit written into reality, the heart of Heisenberg's uncertainty. There is no hidden thread to follow with a finger. There is a map of chances. Imagine a hummingbird in fog. You catch flashes here, then there, but never a continuous line. Unlike the bird, the electron doesn't leave a trail you could discover later. It occupies a haze of could be that sharpens into is only when you poke at it with a measurement. And even then, the certainty you gain in one place steals certainty from another. The straight road between A and B simply isn't how the smallest things travel. Now, consider the double slit experiment, that quiet troublemaker. Send electrons or photons, one at a time, toward two narrow openings, and let them land on a screen. If they were just little bullets, you'd expect two bright stripes, one for each slit. Instead, an interference pattern fades in, many bright and dark bands, the signature of waves overlapping. Each particle behaves as if it went through both slits at once and interfered with itself. Ask the setup which slit a particle used, set a watchman, insist on a story, and the pattern collapses into two simple stripes. The act of looking changes what arrives. The straight path hides again. This isn't a quirk of electrons alone. Photons do it. Neutrons do it. Entire atoms and modest molecules can be coaxed into similar dances when the world is cool and quiet enough. The larger the traveler, the harder it is to keep the dance unbroken. But the principle holds. At the base level, the crisp line gives way to a curved field of possibilities. Even inside atoms, where we're tempted to put electrons on little rails, the reality is softer. Electrons live in orbitals, three-dimensional regions where they are likely to be found spheres, dumbbells, rings, and more exotic shapes. Those aren't tracks. They're contours, maps of presence that say, mostly here, less so there. Schrödinger's equation governs how these clouds evolve in time. It doesn't tell you where a particle will be at a set moment. It tells you how the wave of possibility ripples forward. The curves are fuzzy, but still curves, drawn by rules that hum beneath the noise. Then there is tunneling, where quantum softness becomes a tool. Picture a ball rolling toward a hill without enough energy to cross. Classically, it fails and returns. In the quantum world, there's a small but real chance the particle will appear on the far side, as if the wall grew briefly thin. It didn't punch straight through. It used probability to slip past. The sun shines because of this kindness. In its core, positively charged nuclei need to meet and merge. Classically, their mutual repulsion would keep them apart. Quantum tunneling lets them embrace. Without that gentle rule bending, our star would dim. Life would not have warmed and wondered. Quantum behavior carries other surprises. Entanglement links particles so tightly that measuring one seems to set the other's state instantly, no matter how far they've drifted. It doesn't send signals. It doesn't cheat time. It simply reveals that the joint system has a single description, and when you learn something about one part, the rest of the description sharpens. Cause and effect blur the way lines blur at the edge of a shadow. The path forward isn't a single arrow. It's a branching of possibilities that narrows only when events happen. From this soft ground, the ordinary world rises. Chairs do not shimmer. Apples don't blur through tabletops. The haze averages out, trillions upon trillions of particles, each obeying their fuzzy rules, produce the stability our hands can trust. Straightness returns as an illusion of scale, a good approximation from far enough away. Underneath, a sea of curved probabilities moves in quiet. The beauty sits in the contrast. Far out among galaxies, space-time curves and time itself yields to local shape. Close to black holes, hours and years part ways. Around us, satellites gossip in microseconds, so your map can make sense of the street. At the other extreme, Electrons refuse a straight walk, prefer a cloud, tunnel where a wall says no, and share states across distance as if space were a suggestion. And in between, in the human scale middle, our days inherit just enough curve to keep us honest. We live by arcs, the great circles that cross oceans, the gentle delays of sunset through thick air, the small dilation of time between mountain and sea, the rounded corners of blood vessels and bronchi that keep us standing and breathing without fuss. All along, the lesson repeats in new accents. Straight lines are exquisite tools for drawing plans, but the universe runs on bends. Time leans near weight and gives back elsewhere. Light accepts detours and shows us color and depth for our trouble. Particles choose probability, not rails, and from their wavering, chemistry and life take shape. The more closely we listen, the more the world sounds like a piece written in rubato, tempo shifting with the mood of the room, yet coherent, grounded, and quietly exact. So when your phone finds you on the corner and guides you 3 blocks to warmth and coffee, there's a chain of curved mercies humming in the background, satellite clocks trimmed for speed and height, signals arcing across a round earth, light bending through glass into your eyes, neurons branching their own lightning to make meaning from the glow. None of it insists on straightness. All of it works because it knows how and when to bend. Even the simplest particle, when left to itself, won't march. It wiggles. In a universe knitted from uncertainty, perhaps the most natural posture is to lean, to accept that even the smallest journeys wander. Nature almost never drafts with a ruler. It loops and curls and arcs with a calm that feels deliberate, though nothing is plotting. It isn't artistry, it's survival practiced over eons. Life discovered through countless tiny trials that curves aren't just beautiful, they're practical, efficient, quietly brilliant. What works is what remains, and again, what works is the bend. Hold a snail shell in your palm, and you're holding a lesson that grows. The spiral begins snug, then turns outward in a logarithmic sweep that keeps its shape as it expands. The animal doesn't redesign its house, it adds to a blueprint that scales itself. Strength without waste, protection without excess weight, a smooth geometry that shares stress and shrugs off pressure while guarding a soft resident. The same spiral shows up in ram horns and narwhal tusks, in seahorse tails and sunflower seed heads. Nature repeats the motif, not because it likes matching sets, but because each repetition solves a different problem with the same idea: grow and stay balanced, add and stay whole. Curves grip better, too. A hawk's talon is a pearl of engineering, an arc that concentrates force at the tip while holding fast along the curve. A cat's retractable claw shelters its sharpness in a gentle hook until the fraction of a second it's needed. Straight claws would slide, pry poorly, and dull quickly. Arcs catch, arcs hold. The chameleon's prehensile tail curls into a living spring, wrapping a branch to steady a light-footed hunter. That coil doesn't decorate, it rescues. Millions of quiet edits taught it to perform. Our own bodies are a gallery of purposeful bends. The arches of our feet turn every step into a spring, spreading weight and returning energy. The S-curve of the spine balances upright life with flexibility. It is not the straight mast of a ship, but the supple keel of a dancer. Ribs curve to cradle lungs and make room for breath to widen and settle. Even our instruction book curls. DNA twists into a double helix. A ladder spiraled for stability and compact storage. Easy to unzip when it's time to copy a life. Why do curves keep winning? Efficiency is one reason. Domes, arches, and shells distribute stress without focusing it into fractures. That's why bird bones can be light and strong, why skulls take blows better as rounded vaults, why mollusks can armor themselves without carrying a quarry's worth of rock. Sharp corners hoard strain and breed cracks. Curves invite forces to travel, to be shared. Water prefers a curved channel to a jerking, elbowed course. It keeps momentum without carving chaos. Blood slips through gently twisting arteries and avoids the destructive eddies that rigid tubes would encourage. Curves guide, redirect, and absorb, so motion can continue without wasting itself. Energy rides curves more gracefully than it rides lines. A plant's tendril coils to hold fast with almost no material. The springiness means it can stretch, settle, and hold, even as wind or weight changes. A dolphin's fin swirls water into tidy vortices that reduce drag and boost control, the liquid equivalent of a well-tuned wing. A cheetah's spine flexes, like a bow that stores and releases energy at full sprint. The animal's stride is a sequence of arcs that let muscles and tendons cooperate. Natural selection doesn't set out to sculpt arcs. It keeps small advantages. A fraction more speed, a slightly stronger hold, a tougher shelter kept and passed on. Those slivers accumulate until a curve stands where randomness once wandered. The story shrinks as well as soars. Inside cells, proteins fold into elaborate, curved shapes. The folding isn't whimsy. It's chemistry seeking a low-energy rest attractions and repulsions braided into a stable knot. A molecule's precise curve decides whether it ferries oxygen, catalyzes a reaction, or fumbles the job. One misplaced kink can mean illness. One elegant loop can be life. The same softness guides how membranes bend to form vesicles, how motors like kinesin walk along cellular tracks in arcing steps, how chromosomes coil to fit a library into a nucleus. Curves make room. In sunflowers and pine cones, new parts arrange themselves by turning a near-constant angle phyllotaxis, a quiet rule that packs seeds or scales as tightly as possible without overlap. The golden angle, about 137.5 degrees, spaces neighbors so each claim a fair share of light and air. No tape measures, no overseer, just a simple, local rule repeated at growth's pace until a pattern fills the face. Leaves spiraling up a stem keep from shading one another by the same logic. The plant isn't doing math as we do. The shape itself does the organizing. Camouflage leans on curves as well. Rounded markings, flowing stripes, and soft spots break an outline into suggestion and shadow. A hard edge announces itself. A curve blends into the splintered light beneath branches. Evolution's edits favor what goes unseen long enough to live and reproduce. Even when life uses straight segments, an insect's spiny leg, a porcupine's quill, those pieces live inside systems governed by flexion and flow. Hinges soften, tapers ease transitions. Circular motion returns energy, so the rigid part doesn't stand alone. Movement rarely picks a line either. A bird's flight is an orchestra of arcs, wings, sweeping paths that sculpt air into lift, body pitching and rolling in smooth transitions rather than jerking corrections. Fish swim in sinusoids, waves of motion that start at the head and travel down the body. Deer bound in parabolas that let legs and back share the load. Life moves the way rivers move, by finding the easiest curve that still arrives. We humans like straight tools. Right angles make walls stack, floors meet, roofs rest. Roads with straights are easier to lay and faster to drive when the land allows. The industrial age pressed this preference into habit. Standard parts, regular grids, pumps and pistons marching. Straightness promised predictability and economy. It also seeped into how we organized days and people, rows of desks, boxes of tasks, timetables with little patience for detours. The ruler became a metaphor, yet we kept circling back to curves whenever strength, efficiency, or comfort mattered most. Aircraft wings took their cues from birds, cambered surfaces, smooth leading edges, tapered tips to tame vortices. Bridges leaned into arches to carry weight farther, with less material. Tunnels and windshields rounded corners to quiet turbulence. Even in our pockets, hard boxes have softened into devices with rounded edges because hands cradle curves. Interfaces traded harsh rectangles for rounded buttons, easing the eye and mimicking the ease of touch. In hospitals, catheters and stents follow the gentle geometries of veins. Heart valves are modeled with the same flow-minded math that rivers obey. Biomimicry gave our tools permission to take nature's class. Cities are learning the lessons slowly. Some planners are trading rigid grids for mixed paths and green ribbons that follow the land's grain roundabouts that reduce hard braking. Parks that hug river bends instead of fencing them in. Footpaths that wind to invite wandering. The aim isn't inefficiency, it's comfort and safety. The resilience that comes from giving motion the shape it prefers. Curved streets calm traffic. Continuous greenways breathe better air into dense neighborhoods. Stormwater follows swales and rain gardens that mimic floodplains rather than fighting them with right angles and prayer. Underneath the sidewalks, biological truths keep working. Arteries arc to spare walls, bronchi branch to boost surface area. Nerves fan out like winter trees to gather sensation from broad fields. Even the heart, the metronome we hum to, doesn't beat in square pulses. It flows, depolarization waves curling across muscle, valves opening and closing in choreographed arcs, pressure rising and falling in curves your arteries learn to expect. Look again at the spiral. It is everywhere because it solves many versions of the same riddle. It keeps proportion while scale changes. It lets a structure grow without tugging itself apart. It stores energy like a spring and releases it when called. It spreads things evenly across a circle, seeds, leaves, pores without instruction, beyond a turn and a timing. It camouflages and signals, strengthens and lightens, holds and releases. It offers a path between opposites, rigid and floppy, crowded and sparse, heavy and fragile. The compromises it makes are visible at a glance, yet the math beneath them hums with precision. Even the places we once insisted on lines have softened. Product designers test handles and corners in palms rather than on drafting boards, learning quickly that edges that bite don't get used. Car bodies slip through air with curves that move drag aft and reduce noise. Trains round their noses to quiet the shock when they push into tunnels. Sports shoes cradle feet with arches that echo the bones beneath. Helmets redistribute impact with domes and foam that deform in controlled curves rather than shatter. When life steps beyond structure into behavior, the arcs persist. Predator and prey alike favor turning paths that keep options open, banking routes that watch wind, scent, and sightlines at once, weaving courses that confuse pursuit. Flocks and schools don't square dance, they swirl, each individual following simple rules about distance and direction that produce a whole far more fluid than command and control could achieve. The curve is democracy at speed. Straight lines still help us think, They give us coordinate axes and baselines. Rulers we can lay across problems. They let us lay out scaffolds and budgets and arguments. But they are tools, not commandments. We get into trouble when we confuse the sketch with the subject, when we force square classrooms onto curved minds, when we insist that a life move in 3 stark steps, when we expect feelings to rise, peak, and vanish on schedule. Bodies and cities alike thrive when we accommodate the bend. The curve has always meant thrift, comfort, and reach. It means redundancy, many paths, not just one so a system can survive surprise. A branching river basin knows how to handle a storm. A single straight canal knows only overflow. A network of winding capillaries finds tissue even if one street closes. A straight pipe starves whatever sits just around the corner. The curve distributes risk, the way it distributes stress, broadly, gently, together. There's a soft ethics in this geometry. Curves acknowledge that nothing is uniform, that wind shifts, that loads vary, that living tissue swells and shrinks, that people change their minds. Angles demand compliance. Arcs negotiate. With a curve, you can be strong without being hard, flexible without becoming formless. You can fit more life into the same space. Walk outside and notice how much of your world is already bent in your favor. A handrail that rounds into your grasp. A path that detours around an old tree rather than cutting it down. A cup rim that rests against your lip with a small kindness. A window arch that sheds rain more willingly than a box. A wheel that turns resistance into rhythm. A staircase that winds to occupy a smaller footprint while offering a steadier rise. None of these are flourishes. They are rehearsed answers. And for all the straightness we lay on top of the land, nature's handwriting keeps showing through. A river keeps its lazy S even in a city grid. A hillside tree leans into its own light. A coastline frays. Lightning fans. A shell washes up and starts the lesson again. Life writes where it can and revises where it must. We do well when we read rather than overwrite. There's a deeper humility tucked inside the curve. It asks us to accept that detours are sometimes the route, that elegance is not severity, that resilience is redundancy, that comfort and efficiency aren't enemies. A spiral can be both ornament and engine. An arch can be both grace and strength. A branching plan can be both beautiful and robust. When we admit that, our designs get better and so do our days. So much of what we call progress is the slow return of what was already working. We rediscover that an arched bridge carries weight with less stone, that a rounded building resists wind, that water likes a meander and punishes a straightened river with floods downstream, that a city breathes better with curved parks and messy green edges than with perfect rectangles of lawn. That tools we hold should meet the hand halfway, that policies meant for straight lives leave real lives behind. The curve corrects us without scolding. If you listen, you can hear the same rhythm at every scale. Electrons refuse tidy paths. Galaxies draw spirals that do not collapse. Blood rides arches and lungs grow trees. Seeds pack by turning. Dolphins carve swirls in water, and birds inscribe curves in air. A favorite pen glides more easily along a rounded letter than a rigid one. Even our sleep follows cycles that loop nightly rather than march. Straight lines are superb for measuring. For living, the arc is usually wiser. Somewhere, right now, a ram is wearing a crown of strength shaped by the wind's advice. A fern is uncoiling, a frond it folded earlier with care. And a child is drawing circles because the hand learned curves before it learned angles. Somewhere, a bridge is holding a heavy morning without complaint because its spine is an arch. A surgeon is threading a catheter along a curved vessel. A designer is smoothing a corner and discovering that users sigh with relief. Somewhere, a new shell is beginning at a center and trusting that a turn and a turn and a turn will make a home. There's a hush that lives inside a curve. It's soft where corners bite, yielding where angles insist. It doesn't hurry, it pours. Once you start noticing it, the world becomes a quiet gallery of arcs and spirals, from the moon's patient glide to the small loop of a sleeping cat's tail, from the eddies in your coffee to the whorl of your fingerprint. The gesture repeats across distance and scale, as if the universe signs its name with the same slow flourish from galaxies down to molecules, in lines too vast to hold all at once and too tiny to see without help. We've always called curves beautiful, and they are, but beauty is only the surface of their usefulness. Nature wastes little. A curve guides flow, balances forces, distributes energy, without scolding. An arch doesn't only look graceful, it holds up stone against centuries. A spiral doesn't just charm the eye, it lets a living thing grow without losing its shape. Every coil and curl in the world is working, solving a problem, smoothing a path, strengthening a limb, easing a rush into a rhythm. Practicality composes elegance here, not the kind that's forced into place, but the kind that appears when something is allowed to be what it wants to be, when form follows function and function behaves like water. Old builders understood without equations. Aqueducts walked hills with arches that drank weight and pressed it into earth. Domes lifted air into rooms by spreading pressure like morning light. Vaults lasted because they echoed the sky's curve. Even so, the universe never waited on architects. Its arcs arrive by themselves. Gravity persuades dust to gather and round into spheres. Planets loop in ellipses. Stars knit spirals that keep their shape by moving. What once seemed a flat backdrop turned out to be a flexible fabric that dips around anything with weight. Gravity isn't strings pulling from afar. It's the room itself bowing under what it holds. In those bows, everything finds a path. A photon, fastest traveler, doesn't insist on straightness. Air asks it to turn. Water slows and bends it. Glass gives it work to do. Mass curves the space it crosses. Planets don't carve perfect circles either. They fall and miss, each loop a near spiral around the well that holds them. The universe is full of things trying to go straight and failing beautifully. Even at scales so small we need careful instruments and patient math. Straightness dissolves. Electrons don't march on rails. They gather into clouds, thick here, thin there, regions of likely, not lines of must. Waves describe them, and waves are nothing if not curved. The equations that carry our best understanding, Schrödinger's for the probabilities of small things, Einstein's for the curvature of the big room, speak in terms of bending, of shapes that change and respond. The straight line is an excellent story. It simply fades when the lenses sharpen. Still, we cling to it because it's easy to imagine. A line promises a beginning and an end. It feels like purpose, but lives rarely obey. Thoughts turn around, circle back, take the long way home. Sleep and wakefulness trade off in loops. Growth moves in seasons, not ladders. Learning arrives, recedes, returns deeper. The arc comforts because it tells the truth. Waves aren't lost when they come back to shore. Spirals aren't wasteful when they circle to continue. Rhythms aren't failures of progress. They're the way momentum breathes. We once called curves suspicious. The first careful skywatchers pressed planets into perfect circles and kept adjusting the math when the heavens refused. Ellipses eventually fit better. Later, time seemed flat until heavy places slowed it. Even now we pave in straight shots, schedule lives in columns, grid what will not grid, and rediscover, again, that the world prefers to round. There's humility in realizing that the universe doesn't meet our expectations. We learn to meet its geometry instead. We stop trying to rule it with rulers and let ourselves be shaped by the same patience curves carved by time, not imposed by will. And that becomes a kind of gentle poetry, a quiet bend strong enough to hold a bridge, a spiral generous enough to grow a forest of seeds, an orbit faithful enough to keep seasons, a halo in ice that rings the sun at a set angle, because crystals turn light just so. A curve is not perfect, which is the point. It leaves room for surprise. It absorbs weather. It adapts. It makes channels for flow. It resists by yielding, like willow instead of oak. Strength in nature is more often an arc than a blade. As you move through a universe written in loops, there's a lesson you can hold in the palm of your hand. Elegance lives not in rigidity, but in the gentle strength of a bend. Wisdom isn't always an arrow. Sometimes it spirals inward to gather itself, leans aside to see better, doubles back to gain the hill from a kinder angle. In those detours, meaning appears less like a highway mile marker and more like a tide that never wastes a turn. The idea we began with was small and stubborn. Maybe straight lines are not the native language of the world. Maybe they are our translation, useful, clean, calming, in their certainty yet still a translation. After wandering through galaxies and garden paths, shells and shadows, ribs and rivers, lenses and lightning, that thought feels like a quiet fact settling in. Straight lines make excellent spreadsheets and decent scaffolds, but the terrain is fluid. The terrain bends. The terrain is alive. We still draw them, of course. We build with rulers, because it helps us coordinate bodies and budgets. We speak of moving forward, as if time were a hallway, as if progress were a single arrow. The tools work. They just aren't the world. Their convenience can pose as certainty until you step outside and count the curves you carried back without knowing. The whorl in your fingertip, the coil of your spine on a soft mattress, the slow roll of your breath, the wave in your thought as it softens toward sleep, even the lilt in the rhythm of this sentence as it turns and returns. That's the most comforting part. We don't have to live on rails. We can pause, circle, change our minds. We can grow in spirals that revisit lessons instead of abandoning them. We can tell stories that wander and return more whole. Flexibility is not failure. It's intelligence in the shape of motion. Softness is not weakness. It's strength distributed over time. The unexpected bend is often the door. So here, near the edge where waking thins, notice the arcs close by. The ceiling above you bows a little in the dark. The blanket gathers itself into small hills by your knees. Your breathing draws an easy loop in and out, an ocean in miniature. Maybe your eyes are already half closed, thoughts orbiting slowly, stars beneath the skin. The curve keeps guiding, the way a hand on your back makes a path from one room to the next. Before we fade all the way into quiet, let the early questions return, gentler now, not for answers, only for company. Where are you listening from? What time is it in your small piece of the round world? How does your body feel at the end of this winding path? Perhaps this shape, the loop instead of the line, was the right shape for tonight. Not a charge across the map, but an arc that arrives somewhere softer than where you began. If you're still awake, thank you for keeping me company. If you learned something, relaxed a little, or felt a small smile rise once or twice, a quiet like or a soft subscribe helps others find this calm corner. No urgency, only if it feels kind. And if sleep reached you first and carried you away, that's perfect too. The curves keep moving while you rest. The universe continues its patient dance, clouds scrolling, planets bowing, tides leaning, photons bending, seconds stretching and settling, drawing you forward with care. Wherever the next turn leads, you'll get there the same way rivers do, the same way breath returns, the same way starlight finds your eye, one beautiful curve at a time. And as the room grows softer and the world grows distant, let yourself follow that shape into the dark, a slow, easy arc, fading gently until only rhythm remains.